Hello and welcome to Teach Quant. Today we want to look at an example on how we can apply two-way ANOVA. We want to think of an example of a company that has sales representatives who work in groups and in specific territories, and we want to compare the sales they are able to make. Therefore, what we can basically say that we could say that our null hypothesis will be that there is no difference in mean sales for the different territories and team membership. So that's our null hypothesis. Therefore, we want to come up with why we are using why two-way ANOVA. We have one dependent variable, that is the sales, and then we have two factors. In this case, the territory and the team membership. That's basically what we have. So we are going to create a sample data set. The first one is the one for sales. And for us to be able to do that, we want to keep in mind that we will need the library CAR. That is very important for us. And therefore, we are going to create sales in dollars. The first one is 10,000. The next one is we can have a figure like that. Those are the millions in dollars that we can have, and the last one is that figure. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 of them, and then we do the same for the team. For each of the team, we see what they add. So we want to have two factors. So that's what we have. The first one is we have three territories. Territory C, A, and B. That's the three territories we have. So the three territories will be our factors that we are using. So I'm trying to come up with just a sample example of what we can expect to get. And these are 3, 6, 7, 8, 9. Obviously, the factors should be equal to the number of sales that have been made, so that we are able to capture each team and compare them with the teams and the territory. So the third one is the territory that we want to, as I'm just making it as a factor from the word go. And so the team, it's either in a low zone, a medium one, or a high zone, meaning that it's a well-off section in terms of the socioeconomic status of people there. That's what I mean by medium, low, and high. Those are 8. And then the last one is 9. So let me check how well I'm doing here. It's installing the package, the CAR package. It's pulling it to bring it up so that we can be able to use it. That's well done. Let me see how well I'm doing. Sales is okay, team is okay, and territory is okay. Good. So what we want to do is I want to create a data frame. Based on that, I'll just call it a df data.frame, and then I'll see bind. I'll do sales, team, territory that I have, and I can do that, and I can even go ahead and view my df. So that's what I have in terms of my team and my territories. You can always confirm if your data, the class of your data, if you want to see the class of your sales, it's numeric. The class of the team is a factor, and the class of the territory is also a factor, which is very important for us. So let's see now, before we go ahead, if our data meets the assumptions of two-way ANOVA. One of them is the normality test. You have used a symbol that's not the one I intended. So one of them is the normality test, and we want to test our data. So I'll say norm underscore test. I'll call for Shapiro dot test. Does my sales meet the normality conditions? Good. So let's see. I should have put down here norm underscore test, and I do that, and it shows that my p-value is greater than 0.5. We can see it here. Let me pull it back. My p-value is 0.7986, which is greater than 0.5. So I can say here data is normally distributed since P is greater than 5%, which is good. So one of the conditions is that our data is normally distributed. The second assumption, so let me just call this one A. The second key assumption that we want to look at is what I'll call B. That is homogeneity of variance. And I want to use a specific test. So we want to see if the variance are equal. And I'll use the Levin test, which is here. And I'll look at the sales, I'll look at the team, data is equals to df, center is equals to mean, and I'm there. Let me see how well I'm doing. I seem to be fine with that also. How are we doing on that part? Okay, so what we have now is that again, our p-value is 0.8395, and if our p-value is greater than 0.5, let's find out what does that mean. Since p is greater than 5%, the variances are homogeneous. Therefore, we are okay with that. The true conditions for using a two-way ANOVA have been met. So we want to look at a two-way ANOVA. And we want to start with the additive model. And so I'm going to call it two-way underscore ANOVA additive, and I'll use the AOV. I want to put in cells team plus territory, comma, data is equals to df, and let's see how well we are doing there. There was a message there, there was a mistake which we have to find out. Okay, I see what has happened. When I use 2 at the start, let me use 2 there, and I'm fine. So I can do a summary of way 2, meaning two-way ANOVA. That's what I intended, and that's the result I have. I realize that when I look at the territory and the team p-value is 0.175 and the territory is 0.675, meaning that both of them are not statistically significant. Now I'll come back to that in a moment. Now let me look at two-way ANOVA when there is an interaction. I see if things are different. I'll be a bit lazy. I'll just copy this and then change a few things in the model. Okay, I've just copied that. Here I'll call it interaction, and here I'll call it interaction. That's good. So I have team, territory times sales, and then I see what happens. That's okay, that's good. Now when we look at the interaction between the territory and the team, they are also not statistically significant. So before I make any conclusion, or before I move on, we want to keep in mind that the additive model, theme, and title are not significant. When I introduced the interactions, also they were not statistically significant. So what I want to do is, I would have undertaken a postdoc, but it wouldn't be necessary. Or we could check which variables might have been we want to find out which variables might have been significant, even though the overall model doesn't seem to show any. So I'll use the Turkey HSD test, and I want to see what happens. Sales to team plus territory, and I want to see what I can conclude about that. And then we say data is equals to df, and that is wonderful. So we can ask to get way to ANOVA postdoc here. And what does it indicate? If we start with the territory down here, the low region and high region There was no significant difference between those two. Neither do we get any significance between medium and high legions. For the team B compared to team A, there was a statistical significance of this is 3.17%, showing that team B performed better than team A. Apart from that, the other thing we could do is we could calculate the group's mean. I will start with the team mean and see how they did. We've seen the values there, but just to enrich what you are doing, you could do this and you could get the team mean. So we are going to look at that, and then we come here and we see that this average sales made by team A was $19,710. For team B it was $5,852, and for team C $12,359. And that's why we can see there's a big difference between team A and team B, which is a difference of 13,853. And this figure generally comes from subtracting the difference between 19,710.5 minus 5,852.5. That's how you get the difference between the two. Now, allow me to be a little bit lazy there, and I want to copy for the territory. So, here I'll change there as the territory, then I change this as also the territory, and also this as territory. So I come there and I check why even the post-hoc test didn't seem to be significant. I would have expected L and H to be significant, but it wasn't. It wasn't statistically significant. Therefore, that's what we have on 2A ANOVA. What do we conclude? In the additive and interaction models, the team composition and the territory of sales had no statistical significant influence on sales. Statistical significant influence on sales. So that's what we would conclude from our analysis today. Remember, this is an example to give you an idea of what you expected to do in R, and therefore I hope this gives you an idea of how to go about it when it comes. So if you've enjoyed my video, please subscribe, and then you should be able to enjoy more videos in future.